Hello, my name is Mr. Makras. I'm a student at the University of Cincinnati, and I'm working with Miss Hemsley in chemistry at Withrow International High School. Here is the paper that Miss Hemsley should have distributed to you in order for you to complete this assignment properly. Today we're going to be doing a lesson on ionic and covalent bonds. Alright, to begin we're going to start with table salt, also known as sodium chloride, and in this case in an aqueous solution, which means it's in water. As you can see, we're checking to see if there's a metal in this, and the metal in this one is sodium. So what we're doing is we're going to take a light bulb and take the leads of it and put it into our solution of salt. And as you can see, the light bulb lights up, showing that it is an ionic bond. Alright, next we're going to be looking at salt again, but in this time in a solid solution. As you can see, sodium will again be the metal, and the state will be solid. As you can see in the solid salt, the light bulb is not lighting up. This is representative of no electricity flowing and no electrons flowing through the light bulb, because there is no water in order for the bonds to conduct them. For our next sample, we're going to be looking at rubbing alcohol. The formula for rubbing alcohol is 3 atoms of carbon, 8 atoms of hydrogen, and 1 atom of oxygen, and this is in a liquid state. As you can see, neither carbon, hydrogen, or oxygen are metals. As you can see, our light bulb does not light up in this sample, showing that it does not conduct electrons, demonstrating that it is a covalent bond, then that it does not conduct electricity. Also, you can see that since there is no metal in this sample, it does not conduct electricity. For our next sample, we're going to be using sodium hydrogen carbonate, also known as baking soda. As you can see, our sample is in an aqueous solution, which means it's in water. And we can also look at our formula and see that the sodium is a metal. So when the light bulb is placed in the sodium solution, the light bulb lights up, showing that electrons are being conducted and that this is an ionic bond. Our next sample is sodium hydroxide, also known as lye or caustic soda, in an aqueous solution. Once again, sodium is our metal, and due to the ionic bond present and the metal, the light bulb does light up. The next sample is mineral oil in a liquid form. The formula for this is CHO, carbon, hydrogen, oxygen. When you place the lead for the light bulbs into the liquid, you can see that no electricity is conducted. This is because carbon, hydrogen, and oxygen are nonmetals and will not cause electricity to be conducting, demonstrating that it is a covalent bond. The next sample is potassium iodide in an aqueous solution. As you can see, the metal in this one would be potassium, and the light bulb does light up, demonstrating that electrons are flowing and that it is an ionic bond. Our next sample is granulated sugar or sucrose. The formula for this is C6H12O6. This is in an aqueous solution, and as you can see, the carbon, hydrogen, and oxygen, that none of them are metals. So the light bulb will not light up when placed in this solution, demonstrating that it is a covalent bond. The next sample is antifreeze, also known as ethylene glycol. The formula for this is 2 atoms of carbon, 6 atoms of hydrogen, and 2 atoms of oxygen, and this is in a liquid form. When the light bulb is placed into the liquid, we can see that the light bulb does not light up, demonstrating that it is a covalent bond. Our next sample is Epsom salt, also known as magnesium sulfate, with the formula of MgSO4 in an aqueous solution. When you look for the metal, you see that magnesium is a metal, And then when you place the leads of the light bulb into the solution, you see that the light bulb lights up, demonstrating that it is an ionic bond. The next sample is glycerin with a molecular formula of 3 atoms of carbon, 8 atoms of hydrogen, and 3 atoms of oxygen in liquid form. As you can see, carbon, hydrogen, nor oxygen are metals. So by looking at this, we anticipate that the light bulb will not light up, and as can be seen, it does not, demonstrating a covalent bond. The next sample is calcium chloride in an aqueous solution. As you can see, there's calcium and then 2 atoms of chlorine in this solution. When you look to see if there's a metal in this, you see that calcium is a metal. Then, because of that, we anticipate that the light bulb will light up, and as can be seen in the picture, it does, thereby representing an ionic bond. The next example is distilled water, which in the formula is H2O, 2 atoms of hydrogen and 1 atom of oxygen in liquid form. As you can see, neither hydrogen nor oxygen are metals, so we anticipate that the light bulb will not light up. And as can be seen, it does not light up, so we have a covalent bond here. Our next sample is going to be sodium phosphate. Please correct this on your paper as it says sodium nitrate. The molecular formula for sodium phosphate is Na3PO4. As you can see, this is in an aqueous solution, and when you look to see if there is a metal in it, you see that sodium is a metal. So we anticipate that the light bulb will light up when placed in the solution, and it does, demonstrating that it is an ionic bond. Next, we're going to be looking at tap water. As you can see in tap water, we have 2 molecules of hydrogen and 1 molecule of oxygen. So because of this, we see that hydrogen and oxygen are both nonmetals and that they will not be conducting electricity. However, as you can see, there's a small amount of illumination when we place the light bulb into the tap water. This is most likely because of the small amount of calcium carbonate which is present in the tap water. So the water is in a covalent bond, however calcium carbonate is in an ionic bond. Our next sample is going to be distilled white vinegar. Formula for this is HC2H3O2. As you can see, none of those are metals, so we will assume that the light bulb does not light up. However, we see that once we place it in the solution, there is a small amount of illumination coming from the light bulb. This is a covalent bond, however, it's not completely distilled water, so once again, there's calcium carbonate most likely present in it, causing a slight amount of illumination. For our next sample, we're going to be looking at Windex, also known as ammonium hydroxide, which is NH3 plus H2O, which shows that it is in an aqueous solution. As you can see, there are no metals in this, so we will assume that the light bulb does not light up. However, when you look at it, you see that there is a slight amount of illumination. This is because, once again, distilled water was not used and that calcium carbonate is most likely present again. So the ammonia hydroxide is an example of a covalent bond, but there is an ionic bond going on in the background. The next sample is we're going to be looking at dish soap. In dish soap, there is a sodium compound and it is in an aqueous solution. So for the metal, it's sodium, and due to that, we're going to assume that the light bulb does light up, and it does, which shows that there is an ionic bond present in this product. Here's an example of ionic bonds in a crystal lattice structure. When put in water, these bonds break apart and creating the ions which conduct electricity.
Covalent compound.
Here is a model of hexane, which is a hydrogen-carbon compound which is covalently bonded. Here is the worksheet projected on the smartboard, and it gives you an example of how we completed this exercise and how to fill in your page. Finally, we have finished demonstrating ionic and covalent bonds.